Hello everybody and welcome to our new tutorial. Now this is our exercise here. We want to simulate a projectile such as a bullet or something similar that has a compressible, this flow has a compressible, it is a compressible airflow with Mach number more than 0.3. Now let's start before our analysis, the pre-analysis, by sketching our domain. We go to geometry, make sure 2D is clicked on, and we go to geometry, and it's already opened here. We open design modeler, the second click. Okay, now click on XY plane and click on face, and now let's start our analysis. Let's start our sketching. We draw a rectangle. Make sure before that units are in millimeters. It's good to check. We draw the rectangle and we set the dimensions. Let's set the width as 30 millimeters, and let's set the length as 90 millimeters, and let's go to draw and draw an ellipse. Okay, let me make it a little bit longer. No problem. Now it's a good practice to show you how to use the trim here. Let's you just click on the faces you want to trim, and you can use also the extend, so that you extend lines to the next vertex. Also trim this, we will not need it. And let's stay and modify and use the replicate option. We didn't use it before. Let's click on the first edge we want to mirror, and control click on the two others. Now right click and press and use plane origin as handle, then right click again and flip vertical and go to the origin and just left click here, and here you got your sketch. Now you should go again to trim. Now you can draw it in another way, it's okay, but I just like to show you how to use these options. Here we delete these lines in order to prepare our sketch to surfaces from sketches. Now we press on surfaces from sketches and we just click on one edge, no need for more. When you click apply, it will highlight all the others, and then generate. Here we have the projectile. Now we want to draw the fluid domain, so let's sketch, new sketch, then go to sketching, start by not rectangle, let's start by the circle, go to the middle and make it a bit long. Let's say the diameter, it's 600, let's make it 400. That's okay. Now why I made it a little bit large, it's because that the boundary conditions used are pressure far field, so it is required that we make the boundary a bit more larger. So let's stick to this dimension, and then let's go to draw and draw a rectangle. Let's make it a bit also long. That's it. And let's go to dimensions, and here we V4, let's make it 200 so that it intersects with the circle. And let's go to draw another rectangle. Okay, and let's make it the same, V5. So V5 is 200 millimeters. That's right. Now let's go back to trim, modify, and let's wipe out the axes that are not needed. So we don't need this, we don't need this. Now I pressed 2 times because it's 2 edges, because we have drawn 2 triangles, so don't worry about it. Okay, this one and this one, this one and this one, and let's take off the dimensions. Just set the dimensions. Now let's just edit and delete. No problem. Okay, now let's go to concept and do the same thing as sketch 1, surfaces from sketches. Click on one edge, press apply, and here the program understands that you want to make this sketch. And don't forget to change the operation from add material to add frozen, so that the program will not understand that they are the same part, the same body. They are different bodies. This is fluid and this is solid inside. Now let's go to generate, and here we go. Now we want to subtract these, so we go to create boolean. Target bodies is the large body, apply. Tool bodies is the one inside, so it's the projectile, and we press apply. Now here the program asks you if you want to preserve tool bodies. In our case, no, because we just need to see the flow. We don't need to deal with anything interior here, so click generate. Okay, now we need to prepare for our meshing phase. But before we go to the meshing phase, we need to draw certain lines in the region in order to focus on specific regions that we want to monitor the flow on. So in our case here, I will monitor the flow, or I will focus on the region here, on the flow here. Like I want to have more accurate, the more accurate results on this, and I will draw a line here, so that across the end of the projectile, in order to make an inflation and to see how the flow will go on this. You can also, if you want, you can make a line here so that you can see the flow through the tip of the projectile. But I will not go so deep into this, so I will just stick to this region and the boundary. So at the end of the projectile and behind, and on the boundary layers. So let's start by doing this. We go to sketch, and then we go to sketching section, and let's draw our lines. So let's start from here. Okay, and we go till the end. This is the first line, and now let's say let's draw a line here. Okay, we can draw it a tall one in case we didn't see the letter P here. So, and then we can go to modify and simply trim the outer line. So now this is our new sketch. We go to modeling and we see them highlighted, so we go to concept, and this time we don't choose surfaces from sketches, we choose lines from sketches. And we go here and they are already highlighted, so we just press apply. In case they're not highlighted, just highlight them and press apply, then go to generate and press it. Okay, so now we have this sketch, and what we have to do here in order to be able to work on the surfaces in the meshing phase, we should project these lines into the domain, on the domain. So what we do is we go to tools and we click on projection. So we highlight manually the lines of our sketch. Okay, and we click apply, and the target body is the body we want to project on, so it's the whole domain, and this is very good. Now we generate. Before also we go to the meshing phase, we just suppress the lines in the line body, and the reason why is that because in the mesh phase we do not want to see these lines inside the projectile domain. Now let's go to our meshing. Yes. Okay. Now let's start working on our mesh. So the first thing we do is let's go, and it's a good practice to generate the default mesh to see how it looks. So this is how the default mesh looks. It's not okay, it's not something wow. So let's try to fix it. Let's choose 5 millimeters for the element size, for the global sizing, and let's go to mesh control. Let's go to inflation, and let's choose surfaces, and let's start with this surface. So geometry, apply. This is our geometry, and the boundaries, click on boundary and click on the projectile boundary. So here we click apply, and the maximum layers just 15, I think it's okay, and 1.2 growth rate. Now we proceed and click on mesh control and choose sizing. Make sure you choose edge here, and we go to this line and we apply, and element size we choose number of divisions instead, so that we can it's an alternative to element size where it allows us to assign a discrete number of divisions along an edge. So we choose number of divisions to be 600. Let's choose it. Okay, and bias, we need bias to the side of the projectile. So let's click here and make a bias of 6. Now in order to see if this is right, we just let's zoom in and see if we are correct. I think yes, because it's dense here, it's denser than the end, so it's more dense near the projectile. In case it's not like this, you try the next one, and you will see when you put the bias factor and press enter, you will see where the more elements are assigned to which side. For this, I think it's enough, and for the mesh we chose 5 millimeters, and let's see if it will satisfy us. What? It's okay. Now this satisfies me. It looks pretty good. We can focus here our results. We could also do division for this line by adding sizing also, but it's not necessary. If you like, you can do it. And here you can see the layers with the 1.2 growth layer, which means that it's 20% more the next layer than the first layer. You can see how increasing they are. You can choose one, sometimes I choose, and let's also make just one modification and choose edge sizing. Okay, and click on edges and just divide this into 100 elements. I think it's enough. Okay, number of divisions 100, and bias, yes, the first one, define about 6. Okay, and let's update. Let's generate. Oh, this is nice now. It's better. So let's stick to this result, and let's update and go to the mesh translation to Fluent was successful, and now let's go to the result. Now let's proceed with our work and go to setup in order to make our results. So we choose processes to be 4 parallel. Okay, now we will have the figure here in a few seconds. Okay, now we choose density based since it's of high speed, and we go to transient because it changes with time. Now then the models, let's go to energy, double click and click on the energy, since we might deal with temperature stuff or heat transfer. And viscous, we choose its turbulence, so let's choose one solution of these turbulence. So let's choose K epsilon realizable instead of standard, and let's go to materials, and let's put density of air, let's choose ideal gas because Mach number here is more than 0.3, so it's a pressure far field we're dealing with. So press change, create, then close, go to cell zone conditions, make sure this is fluid, and go to boundary conditions. Now what we forgot to do is to name the boundary condition in the mesh phase, so let's do it now. Just click on the geometry, now go click on this edge, then start clicking on all the edges. Okay, just the outer edges, the boundaries. And now create name selection and just write pressure far field, and let's refresh here so that let's update mesh update. Okay, now let's refresh in order for the new information to come. Now you will see the new boundary condition here. We just wait a little bit, and here it is, pressure far field, and the system understood it that it should be pressure far field. And if we double click here, we see Mach number is 0.6. Let's just set it 0.4. X component of flow direction is this direction 1. That's right. We don't need to do anything else. Okay, and let's initialize our solution. I will choose hybrid and click initialize. Okay, and then we go to solving, create solution animation, and let's go to new object, contours, and let's visualize the velocity. Click on fill, smooth, and let's visualize the velocity on the whole regions we have. Okay, that's beautiful. Close, click on contour again and click OK, and we forgot here to put the number of time steps. Let's put it 100 and let's calculate and wait for it. Now that we finished the calculations, just go to solution animation playback, double click and play, click play, and just you can see your simulation here. Thank you for watching, and if you have any questions, just please keep them comment on the YouTube video, and I will be in touch with you, of course. Thank you very much.